Okay, question H. Triangle ABC's right angled at B and the side lengths are positive numbers in geometric progression. Okay, it follows that tan angle BAC is either, there's some double square roots going on. Okay, so immediately I see a very silly answer, which is D, right? Because as they say, they're positive numbers in geometric progression. So how on earth would the tangent be negative, right? Because you're in a triangle and the side lengths are all positive, right? Okay, so D is already silly. But okay, let's do this rigorously. So now let's make the assumption first that r is greater than 1, just for the sake of, again, for my diagrams. Yeah. So if I draw a right angle triangle here, okay, where's the right angle? So right angle is at B. Okay, so let's say A is here, C is here. Then we have three terms, right? We have A, AR, and AR squared, which is a geometric progression, and we are sure that AR squared is the hypotenuse. Yeah, because I said r is greater than 1. I made that assumption. Yeah. Okay, so the remaining ones I don't know, A and AR. Okay, so off we go. What do I do? Well, right angle triangles remind us of Pythagoras, of course. Yeah, so A squared plus AR squared equals to, well, AR squared or squared. Okay, you guys get what I mean. So and then now the A squareds cancel nicely. So 1 plus R squared equals R to the 4. Right. Okay, so off we go. We have to solve this. Which is quite a pain, to be honest, because this is some quadratic in the sky, we say. So again, we just complete the square as usual. So minus a half or squared equals to 1 plus a quarter, which is 5 quarters. So r squared minus a half is plus or minus root 5 over 2 maybe. Yeah, root 5 over 2. Okay, so now we need r squared, right? So of course r squared must be a positive quantity, right? If not, you can't square root it. So therefore I'm going to take the positive version of this square root here. Yeah, because the negative version gives me a negative answer, so that's bad. Okay, so therefore we have r squared equals to 1 plus root 5 over 2. Yep, so therefore r is square root of 1 plus root 5 over 2. Cool. Okay, so now let's actually answer the question. The question was tangent, which angle was it? Let me just check. It was tangent BAC. Okay. So BAC is this one, this theta. So tangent will be opposite over adjacent, which is simply the r. Okay, great. We're simply the r. Okay, but then now the question becomes, well, why is there an or within these options, right? That's because of the flexibility of the setup. Yeah, so just now I assumed that the AR was down here and the A was here. But then I could also assume the reverse, right? I could assume that AR is here and then A is here. That's also fine. Yeah, I mean AR squared will still be, the longer side. That's fine. Okay, so well, let's have a look then. So that becomes A over AR instead, right? It becomes A over AR. So that's 1 over that ridiculous square root that we've got. All right. Okay. Now let me give myself some space before I try to cram everything onto into one section. Okay, so therefore 1 over that becomes, so that's A over AR, by the way, square root of 2 plus 1 over root 5. And we know how to deal with these things. Yeah, we could rationalize the inside. So this becomes 1 minus root 5 over what? Over, God, can't do maths, 1 minus 5, yes? Okay, so this becomes, the 2 cancels with the 4 down there, okay, and a negative 4, right? Down there is negative 4, so cancels with the, well, it doesn't cancel, it swaps the sign of the bracket. So that's square root of root 5 minus 1 divided by 2. All right, okay, so I have my 2 answers. So let me have a look. Which one looks sensible? It seems like it's C. All right, so there we are.